right? So we're going to look at case 2. Now remember, case 2 for geometric works exactly the same as if it were case 2 for an arithmetic sequence. Firstly, the sequence is not given, but rather any two terms are given. Any two terms of sequence are given. Right? And what you need to do is you need to find the parameters of that. So those are the types of questions. Find the parameters. Now what do I mean by the parameters? In other words, find the first term, which is A, find the common ratio, which is R, and then obviously they ask you to find the sequence, and thereby it becomes a case 1 sequence once you have the sequence, right? Now remember, when we dealt with arithmetic sequences, we solved them using simultaneous equations. So the way we solve is use simultaneous equations, right? Yes. Equations, right? So I'm going to list that over there. Now let's give you a sequence and let's make it very easy. Suppose the question reads T1 of a geometric sequence. Let me just go back. Any two terms of a sequence is given plus its type, right? Plus the type of the sequence is given. So now I'm going to say that T1, which is of course the first term of a geometric sequence, is equal to, let's make it 4. And I tell you that the 10th term, T10, is equal to 1 over 128. And I give you that the sequence is geometric. So this question will read, in a geometric sequence, term 1 is equal to 4, and term 10 is equal to 1 over 128. Find the value of A and R. So that's the first thing that they may ask you. Find A and find R, right? And then secondly, we can tell you, determine the sequence. And then from there on, it is just a straightforward case 1 sequence, right? And then all the questions that you get in case 1 may follow. So how I like to do this is I like to say, okay, let's lay it out. Let's put T10, let's put the highest one first. And then we say that's going to be A times R to the power of 9. Now remember why it's 9, because this position over here represents n minus 1. And when you substitute 10 into the n that has to be over here, it's going to be 10 minus 1, which gives me 9. So I'm going to say AR to the power of 9 is 1 over 128. Right. Okay. And now, furthermore, I'm going to tell you that T1 is equal to just A, as you know, A. Right? And as you know, A is equal to 4. Okay, now when you have to solve with simultaneous equations, you have usually one of two options. You can use what we call an elimination method or a substitution. So you can either use elimination or substitution, right? Now, substitution is usually the common and the popular method when you're studying simultaneous equations, but remember, either of them are valid. So in this case, we're going to take A because A is just equal to 4, and we're going to use the substitution method because A is the first term, T1 is the first term, it's R to the power of 0, which just cancels out. And then that means I'm going to take this A and I'm going to substitute it in there. Okay, so let's see if I do that, what do I get? Okay, so now I'm going to substitute A equals 4 into that, so it gives me 4 R to the power of 9 is equal to 1 over 128. Okay, now I want to divide both sides by 4, or similarly it means I can multiply it by a quarter. When I multiply this by a quarter, I will get, multiply that by a quarter, multiply that by a quarter, right? When I multiply this by a quarter, the 4's cancel out. I'm left with R to the power of 9 all over 1 times 1, which gives me that, and 4 times 128. Let's see what that would be. And so when we multiply 4 times 128, it should give us 512. Right. Now at this point, what happens is you want to try and get everything to a base raised to a power of 9. At this point, you could just take the 9th root on the calculator. You could just take the 9th root of that whole thing. And you could just take the 9th root of that thing over there. And once you take that, this gives you R, because, sorry, that's not Q, that's supposed to be 9. The 9th root on your calculator. And then this gives you R, and that's going to give you 1 over 2, because 1 to the power of 9 is 1, and 2 to the power of 9 is equal to 512. Right, and so there we've actually solved for R. You've got A, right, which was actually given, and you've got R. And now once you have those two things, it's very, very easy for you to actually determine the sequence. So let's do that, right? So T1 of the sequence will just be A. T2 of the sequence will be A multiplied by R. T3 of the sequence will be A times R times by R again, which gives you A R to the power of 2, and so on, dot, 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 dot. Okay, so let's put this in. We knew A is going to be 4. We know A times R is going to be 4 multiplied by a half. And we know the next one is going to be 4 multiplied by a half to the power of 2. And so I'm going to calculate that for you. Either you could have just done it on the calculator by immediately substituting. And so you sit with 4. 4 times a half is 2. 2 times a half is 1. Right, so if I go from here to here, I just multiply by a half. I go from there to there, I multiply by a half again, and I end up with 1. You could have said a half squared is a quarter, and a quarter times 4 gives you 1, and so forth. And then again, the next term, if I multiply by a half, I will end up with a half. And so there you have it. There's your sequence, right? From here on, it becomes very, very simple. You just say Tn equals A, R to the n minus 1. The general term over here is given as 4 multiplied by R, which we solved to be a half, to the power of n minus 1. And when you substitute in any n, you can determine the value of any term if you have its position. So if I ask you what's the 10th term, all you do is you substitute 10 in there. Okay. Right, well done. So that's an example of case 2, but it was a very trivial and easy example, right? What we're going to do next is we're going to use an example where we don't use substitution, but rather where we use elimination, and we want to eliminate one variable.